All right, so I'm recording now. So we were just looking at Gunter's file. In case anybody has this problem, we don't have a solution yet. When he animated the ball, by the way, didn't want to animate that channel, but that's beside the point. He has animation on it and it works. We can't view it in the timeline. It's just not there. We've tried a number of different things so far to solve this, but we haven't actually come up with a solution, including
Well, did we?
right-clicking.
Because all we have to do is press the things in the what are those things called again? The translate Y, translate X.
Channels.
Yeah,
Yeah, that
just click that.
works. So if we just click a channel, but right now I have it set to the other setting, then we can make those things visible by selecting channel box right here. So these are the animation settings, timeline slider or time slider category. If you look here, key ticks, none, active, channel box, and smart. I want to know what smart means because that seems like a really promising thing. But when I switch it to channel box, then they actually did show up in the timeline just for a moment there. But if I click a certain channel, there they are. And it'll show only the keys for that channel, which is kind of cool, but not what should be happening. We should be able to see them right now also. If I set it to active, that's supposed to be showing whatever's animated on that object, but it's not. So I'm not entirely sure what the issue is. But part of the problem is this object had been set to be non-keyable, and you're not supposed to animate it, so it's possible that not having the keys on the correct channels is what the issue is, but I'm not entirely sure. So I'll let you guys know if I come up with an answer for that, but here's another variable right here. You can do display key ticks active from channel box none just by right clicking the timeline, and you have all these options for what it should be affecting. That didn't seem to make a difference either. So interesting. Yeah. So besides all that, we were saying that you shouldn't animate this. I set those to non-keyable. You should move the red one around in the scene and then use the yellow one for the spin. All right. So do you guys have any questions or want me to take a look at your files now that we're into the examples and answering section? For instance, Miguel, what are you doing here? You got questions? I got answers.
Well, I only watched the videos so far. I haven't gotten to the project yet.
Do you have questions about the video?
I really should, but I can't think of anything right now.
Oh no.
I'm
Okay.
sorry.
Well, it's due on
How did you
Wednesday.
set that camera to be able to count the frames?
Oh, my video camera, like when I shot reference.
Yeah.
Okay, so that's a part of this other program called Shotcut. Uh, Shotcut has a filter that will display frame numbers.
Because helped immensely, which
Cool.
made it so that all I had to do was go frame by frame on the video and then just reference where it is on the frame and where it is, and then I was able to animate accordingly.
Yeah. I will show you though that even if you don't have those, you can still get accurate animation from some video somewhere. Let me just open up probably the one that I made, or we could just type in animation reference or something. Let's see. What do we get? Animation reference. Okay, yeah, there's some playlists somebody's made. Let me turn off the audio. No thanks. Okay. So let's just take that for example. I showed that we could frame by frame in YouTube by clicking the comma and period. And so what you
Yes,
can
that
do,
thing is awesome.
so what you can
Comment
do
period.
to figure out both the frame rate and to get the frame numbers is just look at the time code, and the moment it switches from 1 second to the other, you know you're on the first frame of a second. So right here, it goes from 6 to 7. I know that I'm right at the start of a single second. So now I'm going to count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 25. So this video is running at 25 frames a second. So that's really important to know, okay? Because you might have to translate the keys exactly if you're using a different frame rate. But also we can just count to get good reference material. So let's say this jumping guy, we want to know how many frames is he off the ground. Here he's starting off, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I think 10 is where he's struck. So 10 frames at 25 frames per second is what I would write down. Then you might have to do some math to convert it to 30 frames per second. And I could show you guys how to do that math if you really want to. But oftentimes it's not going to be 25. That's a pretty odd frame rate. These people
I think
might
it's
be
24. You just counted the first of both
Oh,
seconds.
I'm sorry, you're right. I was thinking about PAL. In England and parts of Europe, they use PAL, which is 25. But yeah, you're probably right. It is 24. And we could convert between 24 and 30 using the same math if we wanted to. Or you can just estimate based on what fraction of a second that is. So 12 would be half a second then. 6 would be a quarter of a second. So 10 frames is slightly under half a second. 15 frames in 30 frames per second would be half. So bring that down a little bit. 12 would probably be accurate enough. Okay. So yeah, you can actually get accurate reference even without the frames added on. You guys have any other questions about the assignment, how to animate the ball, principles, etc.?
Do you have any common mistakes people make?
Not getting reference at all, not counting it, not making a plan. That's very common. Yeah.
So not doing the assignment.
Correct. Well, think about it. What you're going to turn in is a Maya file. I'm not going to see a chart, a plan, a drawing, anything like that. And so what people reasonably think is, I don't got to do that shit, right? But they're shooting themselves in the foot because this is actually the hard part. The hard part is getting this. The easy part is inputting all these values into Maya and then cleaning them up on the graph editor every time. That's the easy part. And so if you don't do the hard part, your work is going to look a lot more lousy. If you do the hard part, it's going to look a lot better, and the workflow is just going to sail through. It's going to go really fast. So that would be the most common mistake, is thinking that they don't have to analyze motion from video reference, thinking that they can just guess at these frame numbers, thinking that they don't need to make a chart or a plan of any kind, and it always makes the animation look worse. The default that I am aware of from traditional animation and 3D animation is that because your timeline is infinite in 3D animation, it tends to be slow and floaty. People put the keyframes too far apart. Let me just open my rig again. So I have a blank one that isn't doing anything. There we go. So you've just got lots and lots and lots of frames here, and people will sort of pay attention to the frame rate, sort of not, and then just take broad guesses about how long it takes something to go from one place to another. So I'll just put this up somewhere and hit S, and then go somewhere on the timeline that sort of feels right, and move it down and hit S, and then somewhere else on the timeline that just sort of feels right. And then they'll just say, all right, there we go, I made it bounce. Let's play that. Why does it look bad? Why is it floating? Why does it look so slow? And it's because it's not based on anything real. It's like you tried to draw a person without ever looking at a person. It's not a good way to work. In traditional animation, the opposite thing happens. Because you have to make a drawing for everything, people get lazy and they put far too few drawings. So everything gets squeezed together. Move that. Everything gets squeezed together into a very, very small amount of time, and it just flashes past in a moment. And they have to keep adding drawings and adding drawings and adding drawings until it looks right. So, pew, 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 pew. And then there's also really bad spacing in traditional animation because that's something you have to do manually. So they don't have any. That answer your question at least a little bit?
Yeah, that was useful.
Okay. If you did frame analysis, if you did a chart, the next big thing would be not sticking to your plan. And I don't really know why students do this, but they'll do the analysis, they'll write down the frames, they'll make a chart, and then when they get into Maya, they'll just start picking any old thing. They'll just start moving those numbers around wherever they please, thinking that they're doing a good job by shifting them to a place that feels right. And I have no idea what the reasoning is there, but again, it gets out of control and it doesn't look very good. So that happens. After that, it can be not quite comprehending how to use the rig or how to intelligently use the different channels that are available to you. So people will try to do a ball bounce. Let me just delete all that. They'll try to do a ball bounce by moving the thing where it needs to go and hitting S, moving it where it needs to go and hitting S, and doing it sort of like this, where I'm just moving the entire thing, everything, every time. And then they'll just, without ever thinking, do I need those keys or not, go right into the graph editor and try to clean it up. And so from what I just did, now I've got every single channel has keys on it, all the available ones anyway. Why don't they? Was I not hitting S? That's weird. Oh, I never moved time. That was an amateur thing. So I'm going to move time. That was stupid. Gotta move in time first, dummy. So I'm just kind of randomly moving forward in time and then randomly moving in space also, as if I have no plan, because I don't. Okay, we'll just say that. There we go. And then they jump right into the graph editor and try to clean all of that up. But now you've got channels that don't need to be animated with keys that are visible and kind of confusing. We've got everything moving at once, and so we have to try to treat all of these as connected, even though they don't need to be connected. One of the things I show in the video is that you don't need any of these keys on X at all. You just need the overall path of X, and this is a more logical progression. X is moving side to side, so we need the start and end point. Y is bouncing up and down, we need the tops and bottoms. That's all we really need until we want to embellish. And once we want to embellish, then we can add extra keys. That kind of makes sense?
Yep.
Yeah, cool. Well, if you guys
Yes,
don't have any
makes sense.
questions or problems, I mean, that could be the end of it. Or I'm happy to demonstrate, re-demonstrate any of the concepts that were covered in the video.
We're not getting into the actual setup of the rig yet, right?
No. I can
Okay.
show it to you because you're here and you can ask, but I am not going to show how to create this bouncing ball rig. Not as an official class thing, anyway.
All right, no problem.
Yeah,
We'll get there.
if you want to see how it works, then there's a bunch of stuff, but they are constraints and bones and set-driven keys are mostly what's driving this thing. What those things are, the bones are just for the tail. They connect the tail in a reasonable hierarchy that makes it capable of bending one step at a time. The set-driven keys are like for the squash and stretch, where I've got a new channel that never existed before, driving two deformers, or I think it's just one deformer, to do the right thing when I move this channel up and down, as well as the controllers. The controllers are changing size too, because I want them to stay visible. Right? Also, this controller for spin is moving closer and further away from the ball, which is not something that needs to happen, but I'm doing it just for visual niceness. Another thing that's happening is that the skeletal structure of the tail is moving closer and further away from the ball, although not enough, which is why I exposed this to be able to adjust if you want it to. So all of that stuff is being driven simultaneously by one channel. And so what we use is a set-driven key for that sort of thing.
By the way, what's the tail for?
In many assignments in animation, you'll have a simple character before you have a full biped character or animal. And this way you can use a tail to simulate like a little squirrel or tiny creature. You can also use it to practice follow through and overlapping action, which is sort of a response to where the ball goes. When the ball's bouncing up, the tail essentially points downward. And when the ball's falling down, it kind of points upward. but there's more to it than that to create a nice fluid motion. And so this is a very simple, safe way to just use a familiar rig like a ball and a simple action like a ball, and then add on another principle, overlapping action and follow through. Make sense? Hopefully.
Yes.
Yeah, cool. All right, you guys. Anything else, or is that it for us?
I feel like I should have more, but nothing's coming to me.
Okay. Well, you're here, so you're able to ask questions. It is an easy assignment, and I did demonstrate it pretty exhaustively, so it's okay if we don't have many questions this time.
I'm just glad I showed up with mine.
Yeah, it's a good idea. Get some feedback, like a class. All right, you guys, then I'll go ahead and stop recording, and that'll be it for today's meeting. Easy.